difference quotient. I'm going to write the difference quotient right away as f of x plus h minus f of x divided by h. And now I'm going to ask you, do I have this? It's a little bit. I cannot do anything to it. It's done. Do I have this? Yes, of course. It's x squared minus 8x plus 2. Of course I have it. Now my question is, do I have this? And the answer is yes or no.
I have half of it. I think you just plug it in.
Yes. So the answer is perfect, correct. So I have to plug it in. I have to find it. So I cannot put this together just yet. I need to find f of x plus h. Can anyone dictate how to find f of x plus h? What is the preliminary step, first step?
Wouldn't it be x plus h squared?
Very good.
Plus h plus 2.
I'm assuming you said parentheses and parentheses. Perfect. Good. So how many terms we have when we square binomial? How many do we get?
3.
Very good. Awesome. Who said that? Alex. Okay, very good.
Yeah.
Can anyone give us those three?
X squared plus xh, or sorry, 2xh plus h squared.
Brilliant. Thank you very much. Now we distribute. Negative 8x, negative 8h plus 2. Finally, I have this too. Now I will put everything together. And this is how lazy people do it, because they don't want to write again. So this jumps here. H in the denominator. Instead of this, I will copy all this. X squared plus 2xh plus h squared minus 8x minus 8h plus 2. I reach the negative symbol, and I will distribute negative 1 to these three terms. Negative x squared plus 8x and minus 2. At this point, I'm going to say stop, so we can write two notes. Note number 1, every time we calculate the difference quotient, this has to happen first. All terms without h in the numerator. Must cancel. If they don't, I'm in trouble. Right after that, the second one, this is always the first and this is always the second. H in the denominator has to simplify. H in the denominator must simplify. If these two do not happen exactly in this order, then I know I made a terrible error somewhere and I should start from scratch. Okay, so now the equal symbol has a triangle. Look for the triangle next. Okay, so luckily, goodbye, goodbye, and goodbye. So my first step is fulfilled. I'm happy. Now I see three remaining terms. Do you see something in common that I can pull out from those three remaining terms?
Come on, go away. Stop that.
Pull out the h.
Yes. So we will have to factor out h. Good. So can anyone tell us what is left in parentheses?
H
plus 2x.
H is
minus
outside.
8.
H is outside. What is left
Yeah,
in
yeah.
parentheses?
It's gonna be again h because it's h squared, right?
We're talking about the first term.
2x
2x. From the second term,
H
h. From the last term,
8
minus 8.
minus 8. I'm happy. The second condition is fulfilled, and this is it. This expression gives us the slope of the tangent, I mean close, not exactly, as I said, not quite. Very close to the slope of the tangent line at any point on the function we created together. So this is the difference quotient for the function f of x, x squared minus 8x plus 2. I would like to share my screen when you are ready. And first, before that, I'd like to ask any questions, please. Anything. Any questions? Do you all see what's happening here, or you have any doubts or anything? Yes?
I have doubts.
Okay.
So we at the end we had the function h squared plus 2xh minus 8h, right?
You're talking about this?
Yes.
Okay.
At the end, you know,
You mean this?
yeah. But what happened to h squared? Where did?
You see h times 2x is 2xh? Do you see h? Do you see h times h is h squared?
Oh yeah, yeah.
And the h times negative
Now
8?
I understand, because when I was answering your question, I started with h because I put it in a row for myself. H squared plus 2xh. What was left? No, nothing. I'm sorry. I understand.
Is it better now?
No, yes.
Okay, excellent. Any question? It's better to
Yes.
solve all
I have a
questions or many questions in class so you don't have to worry about it at home.
How did you get the final answer, the f x?
This was the function, the original function we started with.
Oh, okay. Okay.
I only said here at the end that this expression is the difference quotient for the function we started with. Is that clear now?
Yeah, thank you.
Perfect. So much better to solve these in class than have to worry and spend a lot of time at home. Very good. So, so let's take a look here by the vertical line test. Is this a function? 44, is this a function?
Yes.
Perfect. What about 48? By the vertical line test, is this a function?
No.
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 Very good. What about 45? By the vertical line test, is this a function?
No.
No. Okay. What else they want here? That's it. Okay. We talked about this. We determined and simplified the difference quotient for a more complex, slightly more complicated quadratic function than they have here. Then we graphed piecewise defined functions. I don't see any. We did look at how to evaluate a function tonight. I don't see anything else that I need to talk about in R.2. So we still have a few more minutes, so we can start R.3, which will not be due on Tuesday, but R.1 and R.2 should be completed by Tuesday. Please, and come back with a list of questions. Now, what I would like to discuss a little bit is just look at some functions and identify their domain and range. So page 32, 32. Okay, so that's R.3. I know I have left, where's my phone? Because only my phone tells me, or you tell me, okay, I have 6 minutes or 5 minutes. Okay. So let's choose a function from here, any function you want, and let's identify domain and range. So R.3, that's all it does, domain and range. Okay, so anyone would like to choose? I will choose then 23. So for 23, I see this function is made out of dots. First of all, I like to see whether it's a function. By the vertical line test, through each point, every vertical line will hit the graph in only one point. I'm happy. 23 is a function. Now I would like to determine its domain. Well, I cannot use the interval notation because the function does not exist at 4 or 4.5 or, I'm sorry, negative 4.5 or negative 3.5. It does not exist at 0. I cannot say between negative 5 and 4. No. I have to specifically, and I'm going to write it down, domain will be written with braces, not brackets, not parentheses, exactly the points I see at negative 5, comma, at negative 3, comma, at 1 and 2 and 3 and 4. So this is the domain of the function. If I make the error to write something like this, that will be incorrect because this function has specific points. Yes, I think I have a chat. Somebody says something. Am I okay? Do we need? Can we email you? Yes, yes, of course. Okay, back here. Let's also identify the range from the smallest. So the domain goes from left to right. The range goes from the smallest to the highest. Of course, because this function has only points, I have to go and write again the range with negative 3, comma, 2, comma, 4, comma, 5. That's it. So they're also asking us to find f of 1. Okay, so back here, can anyone give us f of 1? When x is 1, how much is y?
4.
4. Do we all see it? Please. Now, when we are told f of x is 2, this is y. Y equals 2 is a horizontal line. X equals 1 is a vertical line. But y equals 2 is a horizontal line. A horizontal line at 2 will cross the graph in 3 points. Can anyone give us the x values for those 3 points when y is 2?
Negative 5, comma,
Yes.
negative 3, comma, and 4.
Yes. Here's how we write that situation. So f of 1 is 4, but when f of x equals 2, we have x equals negative 5, x equals negative 3, x equals 4. You could write this as 1 comma 4 as an ordered pair. You could write this how? what is the point for this? What will be the point for this? And what will be the point for this? Which
Two
point?
-5.
-5, 2.
Very good. These are the points we read from. -3, 2, and 4, 2. Awesome. Yes, I will stop. Just let's just look for a second here. Can anyone give us a domain of 26? With a bracket, of course. Bracket at -3, comma,
-5.
bracket at 5. Okay. So for 26, the domain is -3, comma, 5. Indeed. Any questions?